In this video, I'm going to talk about the three types of equations that you'll see. Now, the first type we're going to talk about is an identity. And we have an example here of 2x plus 4 equals 2 times x plus 2. And let's take a look at that. Now, if I solve this equation, I'll start by distributing the 2 on the right side. So that gives me 2x plus 4 equals 2x plus 4. And now when I go to solve and get my variables together, I minus 2x from both sides. And am I moving from left to right or right to left? It doesn't matter because it vanishes. At least the variable term does. So we're left with 4 equals 4. So 4 equals 4 is our result. That's not really a specific answer, but it is a true statement. And that's what makes this an identity, because 4 is always equal to 4. So what that tells me is, it doesn't matter what I plug in for x. Any number in the world is going to work as a solution here. And when we have that, there's a couple of ways we can express our solution set. So one way is to use interval notation. And to do that, I use an open parenthesis, negative infinity, comma, positive infinity, and close the parenthesis. So this tells me any number between negative and positive infinity is going to work as a solution. So any number that exists, that's a real number, is going to work as a solution. Another way of expressing this is to draw the symbol for the set of real numbers. I like this way because you get to make a fancy R. Look at that. That's pretty fancy. So that's another way to express the solution. And a third way is to use what's called set builder notation. So here I have the set of all x such that, so that vertical line, you'll just read that as such that, x is a real number. And this is what you'll see in my math lab. So this is what you're looking for there. All right, let's take a look at our conditional equation. Now, a conditional equation is, let's see, can work with this. Okay, a conditional equation is a regular old equation. It's one that you're used to working with all the time. So here I have 2x plus 4 equals x plus 2. So we're going to get one solution to this equation, and I can minus x from both sides, and I get x. I can subtract 4 from both sides, and x equals negative 2. And this is a linear equation. X is in the numerator. I don't have any radicals. There's no restriction on x, so x equals 2, or x equals negative 2, is my solution. And so I can put negative 2 in braces, and that's one way to express my solution. Or just saying x equals negative 2. There you go. So conditional equation, kind of, you're used to it as boring. Not anything exciting going on there. All right, let's take a look at our inconsistent equation. So this example, we had 2x plus 4 equals 2 times x plus 3. All seem kind of similar. All right, so let's distribute that 2 on the right side, and I have 2x plus 4 equals 2x plus 6. So again, I'm going to subtract 2x from both sides, and I get 4 equals 6. Hey, wait a second, that can't be right. So 4 equals 6 is a false statement. So when you get a false statement, and there's no variable in it, well, I have to have no variable in order to definitely be false. So that means that there is no solution. Okay, and another way of expressing that is to draw the symbol for the empty set, which is that kind of O with a line through it. So those are my three types of equations that you're working with, and you want to make sure that you recognize what types of how to express these solutions for each kind, or if there is a solution at all.